Hi and welcome back. In this video I wanted to tell you a little bit about some interesting Python collections that come built in with the language that you can use for a few different things. So the main purpose of this video is to make you aware that these things exist. Because once you know they exist, later on you may find a situation where using one of them could be useful. Again, going with the analogy of the tools and the construction project, I'm just giving you a few more unorthodox tools that nonetheless could be useful. Normally what happens in one of the situations where we could do with one of these tools but we don't know about them is that we have to work really hard to build one that works well. Instead of doing that, you can just use one of these. So, let's get started with the first one. The first one is going to be a counter. A counter, as you can imagine, allows us to count things. So you can give it an iterable or a mapping like a dictionary, and it will turn it into a counter of elements so you can count how many there are pretty easily. Again, how you do is from collections import counter, and everything we're going to be looking at in this video comes from the collections module. These are some pretty useful collections. Feel free to look up the Python documentation if you want to learn more about these or others that are there. And what we're going to do is say something like device temperatures is 13.5, 14.0, 14.0, 14.5, 14.5, 14.5, 15.0, and 16.0. Let's imagine we've got some sort of thermometer that's been doing some readings, and we want to find out what the most common temperature of our system is. We could do some really contrived thing where we loop over it, we keep track of the ones that we've already seen, we increase one every time we look at it. Generally, I mean, that's just giving me a headache just thinking about it. So instead, we can do temperature. Counter is going to be a counter of device temperatures, and then we can print temperature counter 14.0. So access it as if it were a dictionary. Just access the key that you want to get the count from, and you can see that it gives you 2. And if you go for 14.5, it gives you 3. Pretty simple counter. You can give it a dictionary as well, and it will also turn it into a counter of things. So for example, you could have a counter of greetings, how many times something has been said. Let's say hello has been said 5 times, hi has been said 3 times. Then you can access a particular one, and it will just tell you again how many you've done. So here again you get the 3. This one's not that useful. The official Python documentation uses this example. I'm still not 100% sure on why you would do this. After all, you do have the counts here. You don't need to wrap them in a counter for anything. But I can see the usefulness for a list. So who knows? Maybe I'll find a situation where doing this is useful later on. But I've not yet been able to use a mapping, a counter mapping for anything professionally, but I've used this and it can be quite useful. Okay, that's the counter. Very simple. Again, if you want to learn more about counters, feel free to check out the official Python documentation. It'll be in the further reading lecture of this section, so feel free to check that out. Now, the code for this video will all be available all together, but I'm going to just delete it and go over to the next collection here just to keep things a bit simpler. But the code will have each counter. Sorry, not each counter. We'll have each collection all in the same page. So let's move on to default dict. As we know, when we have a dict such as this one, hello, was said 5 times, for example, and we print my dict hi, we know what's going to happen when we do this. It's going to give us an error. And indeed, as you can see here, we get a key error on hi because it doesn't exist. The default dict never raises a key error. Cool. So that's not it though. Instead, it returns the value returned by the function specified when the object was instantiated. Whoa, that was a mouthful. Let's do some code. From collections import default dict, and what we're going to do is we're going to have a list of co-workers and where they studied. So here we've got a list of tuples, where the first element of the tuple is the name of the co-worker, and the second one is where they studied. So you can see Rolf went to MIT, Jen went to Oxford, Rolf then went to Cambridge to do a master's degree, and then Charlie went to Manchester at the end. Now, let's say we wanted to create a dictionary that maps names to where they've been. Something like this. Rolf went to... I forgot the colon there. Went to MIT and Cambridge. And then Jen went to Oxford. And then Charlie went to Manchester. There we go. Imagine we wanted to make this dictionary, but we only have this data. So an option would be to go over each element and put them in a dictionary. Something more or less that looks like this. We'd create our dictionary, alma maters, which just means places where they've studied. Then we would iterate over our coworkers list in coworkers there. Now remember, coworker is now a tuple. 0 is Rolf and 1 is MIT. So we would say alma maters coworker 0 is an empty list, first of all, and alma maters coworker 0 dot append coworker 1. So coworker 1 is MIT, and what we're doing is we're accessing the Rolf value of our dictionary, which has just been initialized, that's the word, has been initialized to be an empty list, and we're going to append to that empty list the place where he's been. Now this works fine as long as they only appear once. The first time they appear, in this case Rolf, we initialize it to an empty list, and then we put MIT in it. Then we do the same for Jen, we initialize her to an empty list, and we put Oxford in. But then we come back to Rolf, and what we do is we once again set it to an empty list, so we delete MIT, and then we append Cambridge. So we couldn't do this. What we would have to do is say something like if coworker 0 in alma maters, not in alma maters, set the value to the empty list. And if they are in alma maters already, it means we've done this before. We can just append to the list that we've already initialized before. Not the simplest way of working with code. Of course, we can make it simpler by destructuring the tuple here and just say coworker, place. Saves us from accessing the indices separately. We could do this. Of course, this editor removes closing brackets for you, which is not a great feature. So we could do this a bit better, still not brilliant. And as you can see, what we're doing here is also, once again, something that's very common to do, which is to add things to a dictionary if they don't exist yet, and otherwise treat them as though they exist. So what we're doing is, when we don't have an element in a dictionary, we're going to set some default value for it, and after that we're just going to treat it as though it's already there, for example, appending to the list. Naturally, the default dict is here to save us. We can do default dict list. List, remember, is a type. When you have something like this, that is of type list. And therefore, because it's a type, it's a class. Classes and types, same thing. All things in Python are classes and objects. And so this is a class name.